Okay, let's just switch this off and see. The lighting is fine, not a problem. Okay, I think we can see very well. Okay, good day. Good day, good day, good day. I hope you guys are well. I hope you guys are super well. I hope you guys are doing very well. All right, now joining in this live, we are obviously coming through to help with the grade 9s, right? Because we had made a plan to meet at this time. I know I'm coming in a bit later than the agreed time, because we had said, I think we had said 12, right? But then the thing is, yeah, guys, it didn't materialize quite the way I wanted, the 12 o'clock. So that's why you are seeing me now here, right? Just let me know, guys, how's the lighting? Like, if I leave it like this, is this fine? Can you guys see well? Just let me know in the comment section, can you see well if I leave the lighting like this? Or do you guys want the lights to be switched on? What do you think? This? Okay. If you are down with this, is this fine? Or do you want the lights to be switched on? On or off? Let me know in the comment section, on or off. Palulu is like off. Now we see you. What people? Okay. All right. Okay. No, then it's fine. We are going to have them off like that. Okay. All right. I hope you guys are well. I hope you well. Very well. All right. Hopefully all those who are in grade 9 will put your hands up for me, just so that we are on the same page. I just want to fix my my network connection here. Can you guys confirm for me if the network connection is fine? Is the network connection fine? Are you hearing me well? Or is there a lag? Am I lagging? Because we need to clarify those things from the beginning. Okay, Naledi is saying it's fine. Palulu is saying it's fine. Okay, we are saying it's fine. All right. Alrighty then. Okay, so guys, let's do this very quickly. Okay, let us. Okay, guys, yeah, someone actually sent me this paper because they were like, sir, can you go through this paper? It's a grade 9 mathematics mock paper, Department of Education, Free State Province. All right, so because I think this morning I was going through a paper that was provincial June exam. So here's a mock paper for the Free State. Hope you guys can see it well. Ne? We can see, ne? Okay. Then the very next page is this. All right. So I hope you guys can see there. Okay. I hope you can see. Naledi, you have your hand up. Is that your hand up? Naledi. Is there a particular reason why you have your hand up, dear? Okay, Naledi. Oh, sorry, okay. Okay, can you guys see very well there on the screen? I hope you can. Question 1. For each of the following questions, choose the correct answer, circle or highlight the answer you choose. So let's start there at 1.1. Which one of the following numbers is an irrational number? Good afternoon, Sekhametsi. Which one of the following is an irrational number? Is it A, not negative, square root of 5? B, -3, C, 0.3 with a dot on top? Or is it D, the square root? Yeah, the square root of -49. Which one is a irrational number? Okay, so I can see Nathan Dwana says C. Nathan Dwana says C. Nathan Dwana is also requesting, so let's hear. I want to hear what Nathan Dwana. Nathan,
Hello, Mkhulu.
are you well?
Yes, Mkhulu.
Are you in grade 9, my guy?
Yes.
Okay, beautiful. You are telling me the truth. It's not like you are here to eat the children's meal.
Okay.
No, okay. All right. So you are saying C is the answer. Which one of
Yes.
the following is an irrational number? Why are you saying C, not 0.3 with a dot on top? Why are you saying the answer is C for 1.1?
A irrational number is numbers that with 0 and comma. You know.
An irrational number, you are saying, is a number with a 0 and comma.
Yes.
Okay. Now, I hear what you are saying, Nathan.
Okay.
But now, because of what you said, there are a few things I want to clarify for you so that me and you, we can be together.
Okay.
All right. So Nathan, there is your rational number, okay? The definition of a rational number is a rational number is a fraction of integers. Okay?
Yes. Yes.
So a rational number is a fraction of integers. So for instance, if you have A over B, we say that in the numerator, you have to have an integer value. Do you know what an integer is?
Integer.
Yeah.
Integer is number that is like a fraction number or whole number. Yeah, a fraction number there.
Okay. To be specific, Nathan,
It's integer.
integers are positive So if you think about, for instance, 0, 1, 2, 3, ne? And you can go on to infinity, meaning you can go on in the positive direction. So integers, specifically, they have this symbol. Integers are whole numbers.
Okay.
Which also include your negative numbers.
Yes.
Okay. So please, Nate, I need you to know the difference. Integers are whole numbers. When you talk about whole numbers, you're talking about whole numbers that start at 0. They increase by 1 to infinity. Those are whole numbers. Whole numbers start at 0, they increase by 1.
Yes.
Integers, they are the whole numbers, but you extend them to include the negative numbers.
Negative.
Are we together?
Okay. Yes.
So, your rational number is a number that can be expressed or written as a fraction. But a fraction of what? Integers. Are we together?
Yes.
So, at the numerator, you have to have a what? A integer. In the denominator, you must also have a what?
integer.
A integer. And the denominator, there's only one value that we cannot ever have in the denominator. Do you know what that value is? That we can never, ever, ever have in the denominator.
Yes.
What is it?
Can you repeat the question again?
I am saying there's a number in the denominator. We can't have that number in the denominator. Do you know what that number is?
You can have.
Yeah, you can't have it. So from the list of integers, all integers, they are fine in the denominator. But there's one number of the integers that cannot be there in the denominator. We can't have that number there in the denominator. Do you know that number?
0.
Sorry? 0. Yo, my guy. You are with me. You are with me. So in the denominator, the only number we cannot have is that b cannot be 0. Okay?
Yes.
Yeah.
Yes.
So that is what rational numbers are. Rational numbers are numbers that can be written as a fraction of integers. The numerator can be any integer. The denominator can be any integer.
Yes.
But the only exception is that the denominator cannot be what? 0.
0.
Do you know what do we say about fractions that have 0 in the denominator? Do you know what we call these fractions, Nate?
No.
You don't know. Do you have your calculator with you, my guy?
Ish. I left it at school.
You left it at school. Hey, I hope it doesn't disappear, my guy. Hey, calculators at school. Hey, is it safe there at school?
Yes.
Oh, okay. Guys, numbers that have a 0 denominator, we call them undefined.
Fine. Okay.
I hear you saying, does that mean something's coming?
Yes.
Yeah. No, that's
I
beautiful.
forgot this. How come?
Okay. Yeah. A top dog is saying 5 over 0 is 0. No, top dog, in the comment section. Top dog. If you're saying that, then you are demoting yourself. You are not going to be the top dog. You are going to be the bottom dog. So you must make sure that you understand that division by 0 in the denominator. In fact, generally, even if you were to say 5 divided by 0, it's undefined.
Yes. Yes.
Your calculator will say math error. You ever see your calculator doing this stuff? It's saying math error.
Math error.
Yeah.
I'm using Casio.
Oh, you're using Casio. Yo, Casio is the one. Casio does that. When you divide by 0, it says math error. It doesn't say undefined. It says math error. But we need to understand that this meaning of when you're dividing by 0, the 0 denominator, that means undefined. Okay? Yeah. Also, with your rational numbers, you can see rational numbers being expressed as decimals. You know most decimal numbers.
Yes.
So there's 2 types of decimals that you find for your rational number. By the way, they usually use the symbol. The letter Q is the letter that defines rational numbers. So sometimes if they don't tell you rational number, they will put this symbol to represent rational number. Okay? So there are 2 types of decimals. Nate. So Hamid, thank you so much for the roses and all the beautiful gifts. Take care. Thank you so much. You are so amazing all the time. Thank you. I really appreciate you. So decimals, there are 2 types. There is your recurring, thank you Ntamulo, your recurring decimal. Wangwa. Do you hear me?
Yes.
Recurring. So this number, look at this guy. I'm gonna come here. You remember I asked you which one of the following numbers is an irrational. What was your option that you chose?
C.
You said C, ne?
Yes.
And that number that you said is an irrational number, 0.3 with a dot on top of the 3. That
Yes.
number is actually a rational number. It's a recurring decimal.
How? Okay.
When you write out this number, you write 0.33333. That 3 repeats forever.
Okay.
The dot on top of the number is something that is telling us, please repeat U3 always, forever.
Okay.
Repeat U3
Okay.
always, forever.
Ever. Okay.
So this is qualifying my guy as a what? Rational number,
Okay.
not irrational.
Okay.
You are following me, Nate?
Yes.
Yeah. So please, my guy, it's not an irrational number, this guy. And you know what? The recurring decimals can also be expressed back as a fraction. You can convert this back to a fraction. Ne?
Okay.
Yeah,
Yes.
there's a way that we do it. We let x be equal to, we multiply by a power of 10, we set up two equations, we subtract them, voila, we get a fraction back. So a recurring decimal, that's why we're saying recurring decimals are all rational numbers.
Yes.
So if ever later you see a dot on top of a number, it means that that number is repeating. That's why we call it a what? Recurring. The word recur means repeat. If tonight, Nata, you have the same dream that you had last night, then it means that your dream is what? It's recurring.
Okay.
Yeah. So that's important. Sometimes, guys, if they don't put a dot, they put a horizontal line above the number that is repeating. Or
Okay.
we can say the numbers that are repeating. So for instance, if you have 0.83 and then there's a horizontal line above 83, it means 0.838383. So there is a recurring 83 forever.
Okay.
Okay?
Okay.
So I need you to understand that and never misconfuse it to think that a recurring decimal is a irrational number. It's a rational number, a recurring decimal. That's your first type of decimal that is recurring, that is rational. Your second type of decimal that is rational is what we call your terminating decimal.
Okay.
What is terminating? The word terminate. Do you know what terminate means?
Terminate. I think it's a first to hear that.
I'm just asking about the just the normal definition. Not necessarily. I'm asking you about terminating decimal. Do you know what it means when you say you are terminating something?
Not terminating something. No. Don't think.
Have you ever watched Terminator, my guy?
Terminator.
The movie, yeah.
I watch.
Yeah, Terminator. Terminator, my guy. There's a lot of killing there. I just take out, remove completely. You see?
Okay.
Yeah. So the
Hmm.
word terminate means to remove total. You can see the Prosper Sahara is saying to remove something totally or to end something. Or you can say
Okay.
it means to bring something to an end. Yeah. So if you have, let's say, 5,23, the decimal ends where at the second decimal place. All decimals that are ending at a particular decimal place, we call them terminating decimals.
Okay.
Yeah. So this one is ending at the second decimal place. This one is ending at the what decimal place, Nate?
Did oh. Understand?
Not comma 7 is ending at the first decimal
Yes.
place.
Yes.
2,5897. That one is also ending where we count 1, 2,
Two,
3,
three,
4.
four.
Fourth decimal place.
Four.
So in essence, whenever you round off something, you are actually
Yeah.
making that particular decimal to what? To terminate.
Okay.
Yeah. So I need you, Nate, to understand that rational numbers are what I've explained to you here. That's the numbers that are rational.
Okay.
When you speak about irrational numbers, you are talking about the opposite, my guy. The opposite of rational. So that means
Yes.
these numbers cannot be written as
A
a fraction
fraction.
of what? Of integers.
Integers.
They can't. Irrational cannot be written as a fraction of integers, where both your numerator and the denominator are integers, and where the denominator cannot be 0. The irrational number cannot be written as such.
Yes.
So for our examples of rational numbers, if you take, for instance, the square root of 5, this is an irrational number. The square root has
Oh.
a non-perfect square number
Number.
inside. Non-perfect square.
Square number.
Then you will notice something about the types of decimals that you get for irrational numbers. They are like literally the opposite. They are non-recurring and non-terminating. When we say none, it means they do not repeat forever and they do not come to an end. No repeat, no end. No repeat, no end.
Okay.
So if you take the square root of 5, you put it in your calculator, you're going to see something interesting, and that is, hey, that number, it goes up until the end of your calculator, my guy, that number. And you find that there is no repetition forever. There's no repetition forever. And that number, the calculator actually stops that number. But if you were to have something called an infinite calculator, let's say we were to open your calculator and open it up from where you are, let's say to America, you would see those numbers moving, my guy. A lot of numbers. They are going on, but there's no repetition. There is no stop. And even if you get to America, it's not like those numbers, they continue and stop at America. No, they continue forever with no repetition and no termination. So square root of 5 is an example of such a number. It is irrational.
Okay.
Yeah. So please, we must know the difference between rational and irrational. Because if Nata is going to have the boldness to go and do pure maths in grade 10 next year, then Nata must enter into that grade with a solid understanding of those basic concepts of numbers. Otherwise, Nata is going to say that maths is difficult in grade 10. Why? Because Nata didn't bother in grade 9 to master the grade 9 basics. So that's something I just wanted to explain. So if we go back to 1.1, Nata, it's in front of you. Which one of the following numbers is an irrational number? A, the negative of square root 5. B, negative 3. C, 0.3 with a dot on top. Or D, the square root of negative 9.
A.
I mean negative 49. Square root of negative 49.
Okay.
So the answer is
A.
It's A, ne?
Yes.
Yeah. Later, you have understood. Because the answer is A. The negative of square root 5, okay, is an irrational number. What can we say about B? I think whilst we are here, let's see what are the other numbers. Why didn't we choose the other numbers? B is what kind of number, Nate?
B.
Yeah. If I was to say, is negative 3 rational or irrational, what would you say?
Negative is integers number.
Yes, negative 3 is definitely an integer.
Yes.
That's true. I like that. Can we also then say negative 3 is a rational number?
No.
Okay, let me show you something, Nate. Negative 3, you said, is an integer. I agree with you, ne?
Yes.
But now I'm asking, can we also say that negative 3 is a rational number? Can't we write negative 3 as a fraction like this?
Yeah, we can.
Sorry?
Yeah, we can.
Yeah, you can. What's negative 3 divided by 1, Nate? Isn't it equal to negative 3?
No. Negative 3 divided by 1.
Listen. What's a negative divided by a positive?
It's negative.
It's a negative, okay? There's the sign. What is 3? So we are done with the sign. What is 3 divided by 1?
3 divided by 1.
Yeah, what's 3 divided by 1? Because remember, fraction, this line means divide. What's 3 divided by 1?
Yes.
It is?
Divided by 1.
Mm-hmm.
It's 3.
Yeah, it's 3. So isn't negative 3 over 1 equal to negative 3?
3 over 1 equal negative 3.
Yeah. Okay. So negative 3 can be expressed as a fraction. It can be written as negative 3 over 1. Hey, I'm going to say something else. What about 7? Let's say I asked you, is 7 a rational number or an irrational number?
7.
Yeah.
Rational number.
Okay, why? Because 7 can be written as 7 over
1.
Yeah, and the numerator is an integer. The denominator is an integer. So this is a fraction that fits into the definition of what a rational number is. A rational number is a fraction of integers.
Integers.
where the numerator and the denominator are integers, as long as the denominator is not 0. Are you following?
Yes.
What about negative 8? Is negative 8 a rational number?
No. -8
Yeah.
is integers number.
Yes, negative 8 is an integer. But can we also classify it as a rational number?
Yes.
Yes, because negative 8 can be written as negative 8 over
1.
Yeah. So what I'm saying to you is that all your integers can be written as a fraction. Whatever integer I throw at you, 28. Is 28 an integer? Yes. Can I write 28 as a fraction? Yes. Can I write it as 28 over 1? Yes. So what is 28? It's also a rational number.
Okay.
Nate, are you getting this, my guy?
Yes.
Yeah, this is important. All right, and yeah, when you understand the basic of the difference between a rational and irrational number, you've made great moves already just in the number system. Okay, because maths is about numbers. Now you don't even understand the types of numbers you are dealing with. That becomes a problem.
Yes.
Let's look at so B can be classified as a rational number, Nathan.
Okay.
Yeah. C, 0.3 with a dot on top of the 3. What kind of number is that one? Can we say is it rational or irrational?
Rational.
It's rational, right? Why do we say it's rational again?
You repeat it.
Because it is a recurring decimal. You are 100% correct. Remember, we said rational numbers fall under 2 types of decimals. There is either your recurring decimal, which is rational, or your terminating decimal, which is also rational. So yes, 0.3 with a dot on top falls under your recurring decimals, and we know that all recurring decimals are rational. Okay, let's move on. What about D? The square root of negative 49. What is happening here?
Square root of 49.
Negative 49.
Negative 49.
Is this a rational or an irrational number?
Irrational number.
Okay, you are saying irrational number. Okay, it's a pity that you don't have your calculator. I want to check in the comment section.
It's irrational.
What do we classify the square root of negative 49 as? What do we call this? I want the first person to comment in the comment section with the correct answer. I would give them a big round of applause. It's a what?
It's irrational because
You're saying it's rational. Okay,
yes.
I hear what you are saying, but my question is, why are you saying it's rational? Why?
When you put it on the calculator, it will give you a fraction.
Did you put it in a calculator?
I don't have a calculator now, but
yeah. So look at the comment section there. There's a very merciful man who has commented in the comment section. Uzungu at 7478. He has classified the square root of negative 49 as an imaginary.
Okay, Jesus.
Do you know what imaginary numbers are?
Imaginary numbers.
Another name for them is we say they are non-real. Okay.
Oh.
Yeah. And if you put these numbers in your calculator, what you get also, you get maths error. But this meaning of maths error is different from the meaning of maths error for numbers that are divided by 0.
Okay.
I repeat this. Division by 0, we said, is undefined. Okay, so we say these are undefined. Yes, calculator gives us maths error, but we understand this to mean what? Undefined. This, where you have a negative number inside a even root. Any negative number found inside a even root, we call imaginary number, or we can say non-real. The meaning of maths error is different for when you have a negative number inside a even root than the meaning of maths error for when you are dividing a number by 0. This one means undefined. This one means non-real.
Yeah.
Okay? So non-real, we cannot say non-real is rational. No, it's not. And we cannot say non-real is irrational, because it's not. Non-real is non-real. It's on a league of its own. All right?
Okay.
So please, let's never forget that. So that's why from all the options that we had there, we only chose option A for 1.1. And did you see now I've taught you a whole entire lesson about distinguishing between numbers just from that question. 1.1.
Yes.
Does that make sense?
Yes.
Do you have any questions, Nate?
No.
Any questions at all?
Oh, I don't have.
So we can continue.
Yes.
Okay. Amo, how's it?
I am good, and you?
I am doing very well, thank you. Were you writing today?
No, sir.
Oh, so you've been chilling hard.
Yes.
Oh, okay. What have you been chilling doing? Have you been studying? Have you been chilling, just chilling?
Well, I was just chilling.
Is it nice chilling?
No.
Are you getting cold?
No, sir.
Oh, okay. So 1.2, you've heard my sermon, right? I've been preaching. What did you think of my preaching? Were you listening to my preaching?
Yes, I was listening, but I didn't hear all of your explanations because I was kind of busy.
No, it's fine. It's no problem. I understand. But I hope for 1.1, you would have chosen the correct option. Which one of the following numbers is an irrational? A, B, C, D.
It's
1.1.
A.
You would have said A. Okay, which is 100% correct. Okay, let's move on. I saw you actually requested, so I thought let's let you answer that 1.2. Which pair of integers are a sum up to 5? Which pair? Is it A? Is it B? Is it C? Is it D? Or is it A, B, C, D? Which one is a pair of integers that are sum up to 5? Or integers that sum up to 5? Okay, Shami, I see your answer in the comment section there. Andy, I see you there as well. Thank you for your answer. Amo, you still there?
It's A.
You're also picking A. Why are you saying A? Explain.
Well, it's because 5 and 0 sum up to 5.
Okay. 5 and 0 sum up to 5. What does sum up mean? What does that even mean? Like if you were to write it down, what would you be writing down? Give me the mathematical expression of what you mean. So what would you write down? Hey, boy, is this question too hard that I'm asking, guys? Do you guys understand? Because I just want to see if people really, because I hear what you're saying, but I'm just saying, would you be able to write down what you mean? Yes, Shami, thank you so much. So
Yes,
5
yes.
plus 0, right? That's what you would
Yes.
write down. Yeah, 5 plus 0. Because it's one thing to know, but it's another to write down. Imagine if this was a question and they said, please first express the mathematical meaning of what you are saying, and then thereafter provide the answer. So 5 plus 0, that's what it means. Thank you so much, guys. Very good. So Amokhela is 100% correct. It is A. I agree with her. Okay, let's move on to 1.3. 1.3. 1.3 is saying find the length of the rectangle below if the area is 3,528 times 10 to the power of 5. Okay, find the length of the rectangle below if the area is 3,528 times 10 to the power 5. And you can see in the diagram, as they are saying not drawn to scale, there is a length that is already provided. The short side, we are told, is 4,2 times 10 to the power 3. And so then they are asking, find the length of the rectangle below if the area is 3,528 times 10 to the power 5. So your answer for A, 35,28. B, 8,4 times 10 to the power 5 is the option. C, 12,6 times 10 to the power 5. And then D, 3,528 times 10 to the power 5. So my lovely guests, I can give you just a minute to sort of like see what you can do on your side, and then I will request your answers and what you think, your thoughts around the answer. Okay, I see an answer there from Andy Dandy. So let's see what Andy has to say. Andy,
So,
hello, how are you, Andy?
I'm good, and yourself?
No, I'm doing very well, thank you. You have confidently said in the comment section C. And it seems
Yes.
like the comment section is very silent. I think people are taking in the problem. You know, people are usually
Yes.
eager to answer, but you answered very quickly. So I am interested in your thought process. How did you go about getting to C?
So they have already gave us one side. So I just
Yes.
multiplied the sides by 3 because we have 3 sides.
Okay, you have 3 sides. So what
Yes.
did you do? You said you multiplied. Okay, I'm gonna
Yes,
just
by the number that they gave us.
Okay, let me just I want to do a rough drawing of this, and then yeah, we can sort of like view what you are saying. So we were given the area. The area is given to us. It's 3,528 times 10 to the power 5. Then the length of one side is also given. It's 4,2 times 10 to the power of 3. All right. So I just want to move this down to the power of 3. So you are saying, Andy, if I'm hearing you correctly, you are saying we would do what?
I think we're gonna multiply by 3 to get the answer.
So since we are given this side, you are saying to get the lengths of the other side. Or you're saying to get the length of the one side, we are going to multiply by 3.
Yes.
Yeah. Find the length. Obviously, the length is the what? It's the long side. The breadth is what we've been given. So we want the length. We've been given the breadth. Short side is given to us. We want the long side, the length. So you're saying we should multiply what? This by 3.
Yeah, let's see.
Yes, I'm thinking, so I'm just thinking.
No,
think
no
so.
problem. It's good to think. That's what we want, right? We want people to think. So multiplying this by 3 because you are saying we don't have the other 3 sides. Remember, this is the length of this side. What type of shape is this? We were told it's find the length of the rectangle. Are we together?
Yes.
Yes.
So would it help us to multiply this side by 3 for the rectangle? And just as we are thinking around what you've said, would it assist us to multiply this side by 3 in order to get the length? Because remember, by the length, they mean they want the length of this long side. Would that help us?
No, no.
Okay. So that's what I wanted us to be able to at least clarify. So that means we had a bit of a misconception, which is fine, Andy, because part of learning is actually exactly that. We need to, sort of like weed out the misconception so that we can bring the clear understanding of what we have before us. Okay. So I don't know, do you wanna take another shot at it? Is there something else that you've been thinking?
Question. Yes, I want
Sorry?
to see the question.
Okay. Now I love what you are saying, Andy. Because you're
Nice.
saying to me, you want to see the question. Guys, can I just say this? Please make it a point that before you answer questions, analyze the information that is given. Like you need to spend a bit of time analyzing what you are given and make sure before you answer, you have seen everything that you need to see from the statement and the diagram. You see, if you look at 1.3 and if we read it again, it says find the what? The length of the rectangle below. Then when you take your eyes to the rectangle, you look at it, you're like, Haibo, this rectangle already has a side that is given. What is that side? It is the breadth, or we sometimes call it the width of the rectangle. The width or the breadth, the short side of the rectangle. Okay. Then maybe when we think of rectangle, we start thinking of properties of a rectangle. All right. Yeah, some of the properties. Okay. Then let's leave that. Then the statement continues. If the area is 3,528 times 10 to the power 5, what is the length? Then you look at your options and then you go back to the diagram. And then you can apply your thought process or your thinking accordingly. Okay. So Andy?
Sir,
Yeah. You've seen the question. Is there anything else that you have thought? Or should I
I'm
tell you?
thinking it's maybe B.
You're thinking it's maybe B. Why B
Yes.
specifically?
Because when I multiply the numbers that they gave, the area and the width that they gave us, in the calculator is giving me 14 comma something. When I round it off to the decimal of 2, wait, 2. But it's still the same.
Okay. All right. So let's back up a little bit again. Nata, is there anything you're thinking of?
I'm coming now. I'm coming. Ish. This is
Okanye, do we need to enlist the help of Mr. Jordan? Jordan, I think, is like ready to go. Jordan.
Yes.
Are you well, Jordan? Are you wanting to help us here? We need your help.
Yeah. I can help. I can try.
Okay, help us, my guy. 1.3. What is your thinking?
Me, my thinking, ne? I think since the breath, ne, it's 4.2 times 10, 3 to the power of 3. Maybe the length will be times 2 the size of the breath.
Okay. Times 2 the size of the breath.
Yes, which is gonna be 4 to the power of 3. I mean 8 to the power of 4.
Oh, so you are saying your answer is B.
Yeah.
Just like I think Andy was also alluding to the same thing. Is that correct, Andy?
Yes, because when I
Okay.
punch the calculator, it's giving 8,400.
Because when I punch in the calculator, okay, I hear you guys.
Yes.
I appreciate your contribution. Let me get one more person and see what thoughts do they have. I appreciate all of your thoughts. Right? It's really it's exciting for me. This people are really we are thinking here. We are not sinking. We are thinking. I'm just gonna give just one last person, then we can look at.
I never.
I never exclusive.
Move. Stupid.
Hey, some people they join this live and they request, but they don't want to request. They request, but they don't want to request. Hello, Sprinkles.
Hi.
How are you, Sprinkles? Awesome. There's 1.3 here. I just want a concluding thought on what someone else thinks. We've had we had two thoughts about how to approach 1.3. What do you think? Have you been looking at the question? We're looking at 1.3.
I just joined the live and could I just have a few seconds to craft it down on a piece of paper?
No problem. Craft it down on a piece of paper. We will sort of like allow you that privilege. Thank you, Pabalo, for the ice cream. Yeah, it's nice for ice cream to be cooled down there. Cooled down very nice. Pabalo motswaneng. Ke a leboga ntate, ke a leboga thata. So yeah, I'm just gonna give a chance, and then we will There's a reason, because I'm hoping all of you as well, if there's any other additional thoughts you might be having around the question. Of course, if there's no other additional thoughts, you've concluded that it's B, then great. So I know that most of you are going to be like, but term 1 and term 2, we didn't do area. But you see now they are incorporating the knowledge, they are incorporating things that you've done in previous grades as well in this paper.
Sir,
Yes.
3,5 to 8 multiplied by what there? I can't see.
By 10 to the power 5.
Okay.
Who said Who said
So why are the exponents not changing? Yo.
Oh man, why are you guys killing me?
They're not changing.
They're not changing the exponents.
Yes, the exponents.
So Sprinkles, are you winning there?
Almost done.
Almost. Oh, okay. All right. Because I don't want to be the one that eats the children's meal.
It's A. Hi.
Who said it's A?
It's. I
Andy,
don't know
you
the
changed.
name.
Andy, you're
I'm not
changing your name.
changing. I'm not changing. I'm saying it's B.
Yo, yo,
I thought for a
I
moment it
think
was
it's C. It's
Nita is saying it's C. Andy is saying it's B. Jordan said it's B. We would love to hear any other deviations. Kimi Visuals is saying it's A in the comment section. Kimi.
How come?
We shall see.
We shall see. We shall behold. Because the length multiple by 2.
It's B.
Who's saying it's B? Andy.
B.
Oh, Andy's
Yes.
saying it's B. Okay.
The answer is B as well.
So Sprinkles, you're saying the answer is B.
Yes. Because
My question then, Sprinkles, is how did you get to B?
how did
You can just unpause yourself so that we can hear what you're saying.
we have length, right? Which is don't have length, so we're going to say area.
Okay, just wait, hold a sec. You said we are going to say we want to say area, yes?
No, we're going to say length is equals to area over width.
Okay. But firstly, where is that all coming from first? It's coming from the formula, right?
Yes, because we are given the area and we're also given the width.
Okay, that's very important because I mean, for anyone to be able to make sense of this first, we need to start at the point where we are familiar. So this is the rectangle, right? So the area of the rectangle, the formula that we should all know is the one that says length times breadth. We have not forgotten that, ne?
Yes.
Yes. So then you are saying, go ahead, Sprinkles.
We have the length, so we're going to say length is equals to area over width after we have our formula.
Okay, we are going to say length is equal to area over width or area over breadth. Okay. Then
By which we're going to put the numbers in place of area and width. I don't know how to say it, but then
3,528 times 10 to the power 5. We're going to substitute the area in the place of area and the width in the place of the width or the breadth. Because remember, guys, breadth and width, we're basically meaning the same thing. So 4,2 times 10 to the power 3. Okay, then
we are going to, I first did it with the decimals and I said 3,528 divided by 4,2 is equals to 840.
840.
And then I subtracted the powers of 10.
Thank you, which is what?
Which
Bases
is
are
5
the same.
and 3.
5
10 to the
minus
power
3.
of 5. 10 to the power of 5.
Mosi, you are dividing. The bases are the same. So you keep the base, you subtract the
I'm
exponent.
going to subtract. And then we get 840
Yes.
times 110 to the power, 100 to the power.
Okay, we can say 10 to the power 2. It's fine. We can
Yes.
say 10 to the power 2. Then
I put it into scientific notation, which
very
I got
good. When you put it in scientific notation, that means
8.4 times
Exactly.
10 to the power of 4
8.4 times 10 to the power
of 4,
of 4,
which gives us the length.
which gives us the length. Now, guys, can you see what's happening there in the comments so when you said 3,528 divided by 4,2, you got 840.
Mm-hmm.
Can we all confirm that? Like 100%?
Yes, sir.
Okay. Confirmed, right? Then, after getting that 840 times now 5, because it's 5 and 3, and it's not 5 and 2. 5 minus 3, that gives us 10 to the power 2. If we move the decimal twice to get 8,4, that's times 10 to the power 4. It's not 10 to the power 5. That's if you guys' calculation is 100% correct. Do you have an option that says 8,4 times 10 to the power 4 here in the letters?
No.
Okay. So what does that mean?
It can mean that the person who said that paper can be wrong, or their
Amen.
calculation can be wrong.
Amen. But we can clearly see, right? If you guys are saying your calculations it's everything 100%, then it means that the error is not with the answer that we got, but the error is with the setter of the paper, which happens. I'm not gonna lie, guys. It happens. Okay. Yeah. So that's where learners would be complaining and be like, "Hi, Bo, what happened in that question? That question didn't have the right answer. Who was setting that paper? No. Yeah. Okay. So, yeah, but the calculations are 100% correct. The concept is what we want to actually make sure that we all understand. Okay. So does anyone have any questions about how we got to the answer
No.
in the panel? Are we all clear?
Yes.
Okay. Okay, then we can move on then, guys, to the next beautiful multiple choice question. If there are no cries at all, no one is crying, everyone is saying we are happy, we are happy, then I am happy too. Next question. Next up. 1.4. 1.4. Ilani, how did we get 840? They said that they divided 3,528 by 4,2. You divide these two, you get 840. Unless you can say to me, no, sir, it's actually 8,400. If that is the case, then it means Sprinkles did a number on us.
So we must divide by the 4,2.
Yes.
It's giving me a fraction.
Yeah.
It's giving you a fraction. So 3,528
Yes.
divided by 4,2 is giving you a fraction.
Yes, it's a fraction of 0,84.
Okay, wait a minute then. Just a sec then. Oh, there we go. Okay. Then let's do this then. Let me just switch over. I'm trusting you guys. Okay. I am trusting you guys. Trusting you with my life. Okay. Let's check then. It's not a train smash. It's not a train smash at all. It's not a train smash at all. Let me just, sorry guys, a sec. Just bear with me here. Okay. So we are saying 3,528. So 3,528 divided by 4,2, you got what? Not comma?
0,84.
0,84. Okay,
Yes.
if you got 0,84, then 10 to the power 5 divided by 10 to the power 3. Remember, when we are dividing same bases, we keep the base, we add the exponents. So we get 10 to the power 2. Yeah, because the bases, we keep them when we are dividing, we subtract the exponents. So we get 10 to the power 2. Then we move the decimal to the right so that we can get a number between 1 and 10. Because remember, scientific notation, the most correct or the most appropriate way is to actually write the number between 1 and 10. So if we move the decimal once to the right, what does that mean?
8,4.
Okay, 8,4, right? But then
Yes.
how does that affect my times 10 to the power 2?
Now it changes.
It changes to what?
So is the exponent going to change?
I'm asking, I'm asking you guys. Don't ask me. I'm asking you.
Okay. Okay.
I'm the one asking you guys. So if you are moving the decimal to the right, what does that mean? What are you actually doing if you're moving the comma to the right? Yes, the exponent of 10 is going to change, but it's going to change to what? That's my question. LHI the Great, the reason why we move the comma to the right is because scientific notation says you need to express your answer as a number between 1 and 10. Okay? Times a power of 10. Okay? So this here needs to always be a number between 1 and 10. So the reason why I'm moving the comma to the right is so that I can have a number between 1 and 10. Okay? I hope that makes sense. Okay. But what does moving my comma one decimal to the right mean for the exponent? It means it's going to be multiplied by 10. That's what it means, guys. You subtract the exponent. From the exponent, you subtract 1 because you moved the decimal to the right. So you subtract 1. Remember, if we were moving to the right, we would add to the exponent. Just like we had done here. You remember when we had 840, we moved 1, 2 to the right. And what did that mean? It meant we added 2 to get 10 to the power 4. That's when we had actually made an error or a mistake about the division of these two numbers. It's not 840. You guys are saying it's actually 0.84. Is that correct?
Yes.
Yes. So now it's times 10 to the power 2. But then, of course, if we move the comma so that we can have a number between 1 and 10, then and we're moving to the right, then that means we subtract from the exponent to just 1. Because we moved once, we subtract 1, we get 8,4 times 10. That's the answer. Okay. If we are expressing it in scientific notation. Still, that is not reflected where? In the A, B, C, or D that we have there. Hence, I'm saying this is a situation where I think they made an error. They made an error in the options that they presented. And we can't change anything about that. Exactly. All right. Okay, epic. So let's move on, guys. Let's move on to the next and to the next, because the next is waiting for us. So we are here now, 1.4. Let's try and move a bit. Yeah. Okay, Nata, in the pattern, -4, -7, -10, -13. What would the next term be in the pattern? Is it A, 3, B, -16, C, -3, and D, 16? So I'll give you 30 seconds to just sort of like hlengarisa your answer, and then you can.
It's a B,
Yeah.
yes.
B.
Oh, you guys are so fast.
Yeah, it's a B.
Yeah, fast like lightning. Okay, you guys are saying it's B. Seems like you have a consensus that it's B. Negative 16. KB Visual is saying, so LHI degrade. Hey, I am scared of that answer you are giving there. Negative 3. How come? Hey, guys. Okay, so we look at the pattern, right? If I was to ask, what is the constant difference of the pattern?
-3.
Yeah, the constant difference is negative 3. Maybe LHI degrade is actually answering that. I think, oh, I see. Yes, LHI degrade. I was thinking to myself, how in the world can this guy say the answer is negative 3? So you were answering the point that the constant difference is negative 3. So because the constant difference is negative 3, of course, we are adding negative 3 throughout. Okay, I love that. Then the answer, though, is B, right? Okay, good job. Good job to all around the house. I think we, for the most part, all got that one. 1.5. Let's move to 1.5. Study the diagram pattern below. Each diagram was created using matchsticks. The table below gives the number of matchsticks in each figure. Figure 1. How many matchsticks do we have? We can see it's actually tabulated there in the table. Figure number 1 has 4 matchsticks. Figure number 2 has 7. Figure number 3 has 10. Figure number 4 has 13. And the figure number 5, there is no number present. In what?
16.
You guys are too fast for my liking. Okay, then what is the representation of the pattern? A, B, C, D.
B.
It's B.
Wait, guys, what are we actually saying here?
Okay, term number here. So we are going to substitute the figure number into the formula, and then we're going to get the number of matchsticks.
Okay, so
The
when you
answer
see,
is B.
so the answer is B. Okay, speak to me. Let's see you actually do the substitution yourself and actually claim what you are claiming.
I will say time is ticking. If we substitute 3n plus 1, we're going to say 3 open bracket 1
Yes.
close bracket plus 1,
Yes.
which is 3 plus 1, and then we get 4, which is the number of matchsticks.
Amen. Amen. It means the number of matchsticks. It's indeed.
Yes.
Okay.
Okay, and then you can do that for every consecutive figure number.
Yes, to get the number of matchsticks. The matchsticks, yes.
Okay. All right. So that is the quick. So that is the quickest way to actually get TN.
Yes.
If we were solving an actual problem and they wanted TN, they wanted us to find what TN is. Are we also fluent in knowing what to do if we were asked to find TN and TN was not given to us?
Yes.
What would we do step by step? Because to me, that's important as well. I know this question is giving you the options, but how do we go about finding the nth term if we are given
Okay.
just the number of matchsticks?
So, let me teach you. We are first going to find the constant difference.
What is the constant difference?
The constant difference is when we subtract term number 2 minus term number 1. That's the constant difference.
Okay.
I'm not a maths teacher, so don't say no.
No, but
So-
you are a student of mathematics, so you must be in the position to be asked, and you must
So-
be able to respond.
Eish, I'm responding.
I
Okay,
know.
so it's C, D, and then we're going to have a substitution. Can be B, it can be X, it can be Y, right?
I'm listening.
So when we have our constant difference, we are going to substitute it with a figure number. And then when we substitute the figure number, we're going to find the thingy. And then when we find the thingy, we're going to get the thingy.
She's opening her books.
I'm opening because I don't know how to understand. Uncle, it's in my mind.
Oh my goodness, you guys are killing me. You guys are really killing me.
Okay, so it's CD. We get 5. Let's say, okay, so it's CD, it's 3, right? So we're going to say TN is equals to AN plus B. Ne?
AN plus B. Okay.
Where A we said is equals to CD and CD is 3.
Okay. So
And then you were... Are you writing?
yeah, I'm writing because I just want to make sure that we are there.
Why
Okay,
is
so
this
you
not
said
doing-
A. How do I get A?
A, term number 2 minus term number 1, we get CD.
Okay, so guys, it depends how you've been taught. Some of you, I know you have DN plus C in your heads. She is just using letters. What's important here is understanding what the coefficient of n means, which is constant difference in this case, and then of course
Yes.
the value of B. All right, which you can get by substituting certain things there and there. Okay, so it's the same thing. Okay, so don't be shocked about the difference in letters and so forth. It's fundamentally the same thing.
Okay.
So you said that we get that A by saying T2 minus T1, which is I agree with. So that's 7 minus 4 you said, and that is 3. Constant difference, got 10. Then what do we do after that? Okay.
So we're going to substitute 3 into A.
So Tn is equal to 3n
Plus B.
plus B.
Yeah, we're not forgetting the B, Pelan.
Very true.
So we're going to term number, it's, let's say we're going to start with 1. We're going to say term number 1 is
Okay,
equals to 3, and then where we have the number, we're going to put 1 as well.
Where we have the number, we are going to put 1 here.
Plus B.
Plus
B.
B. So since we took the term number for this value, we're going to put the value of 4 there, ne?
Yes.
Yeah. So whatever term you choose, you put the position of the term. So if you could also choose 7 if you wanted to, substitute it in the term, and then the accompanying position of term 2 is going to be, basically you put 2 here. So if you had chosen 7, you would put 7 here, you would put 2
Network.
there. If you had chosen 10, you'd put 10 here, and then you'd substitute the position, which is... Take it away.
Oh. So we're going to say 4 is equals to
Oh,
3 multiplied by
yeah.
1. It's 3 plus B. And then you see that is where the problem is. We are going to start with B because we are switching the numbers to get the thing. We are going to say B is equals to 4 minus 3.
So we transpose the 3, ne?
Yes.
So 4 minus 3 is equal to B. What's the answer?
It's 1 is equals to B now.
Thank you. B is equal to 1. Now, I know most of you are like, I said the B should be this side. Guys, it doesn't matter. As long as the B is isolated and the number is on its own. You want to isolate, ne? So therefore, you know that B is equal to 1. So what is the nth term then? We can conclude now. Tn is equal to what?
Tn is equals to 3n plus 1.
Plus 1. Yeah. Now I know, I see someone, for instance, Kimi Visual is like, it's not B, it's D. Guys, the letters are unimportant. What's important here is to, obviously N, it's a critical one. N has to be there because it stands for position. But whether you write A or D, you write B or C, you write L or M, you write P or T, doesn't matter, guys, as long as you understand that the coefficient of n stands for the constant difference. And then this constant here, you can actually get it by substituting any term with its accompanying position. Okay, so don't panic here. Also, let me just say this as well. Many of you get taught this formula, this one, right? This formula, guys, you know, I don't know, but our South African syllabus is very, I don't know, I could call it very sensitive. So most, or let me say just the syllabus itself, it reserves this formula for when you do grade 12. There's a sort of like discouraging voice to use this formula whilst you are still in grade 8 and 9. All right, even though some textbooks, they take this approach. The thing is, if you are doing the maths and you are in a government school and you are following CAPS, then CAPS opens the way for the use of this formula only in the 12th grade. You know? But you see, some textbooks, what they've done is they actually use this formula in grade 10 sometimes, and even in some cases, grade 8 already, some learners know this formula. But then the CAPS document is saying, no, guys, this we are reserving for grade 12. So as much as possible, if you can, do make it a point that you use this one. That is, this one is only used when you have a constant difference in your sequence. All right, so that's very important. I just wanted to bring that additional note for you guys to take into consideration. So let's continue now. 1.6, given the function y is equal to 3x minus 9, what is the input value if the output y is 0? Is it A, negative 9, B, 9, C, 12, or D, negative 12?
Let me see. I put in 3 brackets.
Okay, Nita wants to answer. So Nita, I'm going to give you a chance. The ladies have been speaking a lot, so let's give you a chance.
Okay.
What were you going to do, Nate, with this one?
Can you wait a moment? I'm coming now. So, it's negative 9.
You're saying it's negative 9. So what did you do to get negative 9? It's grade 9, Neo. Grade 9.
We multiply 0. Okay, we say 3 open brackets. We put
3
0.
open brackets. You put 0 in the place of 3. I mean of 0.
Yes.
All right. Just very careful, Neo, there. I want to stop you from the beginning. They're saying given the function y is equal to 3x minus 9, what is the input? So they want x if the output is y.
Y 0.
Yeah. If the input y is 0. So where are you substituting the 0? Because if you are saying that the output y is 0, where are you going to substitute the 0? For which variable?
So can we help?
I don't know. Does Nata want the help? You can ask. Nata?
Yes.
Okay. You can help.
No, from the way we have 0 there and y. So, say what is the? I can't see the thingy because I have the thingy there.
If the output y is 0, given the function y is equal to 3x minus 9, What is the input x if the output y is 0?
Okay, so we're going to say y is equals to 3x minus 9.
Y is equal to 3x minus 9. So we just wrote down the function.
And if y is equals to 0,
Uh,
we're going to add y to both sides.
if y is what?
9 to the both sides.
Okay, so are we going to substitute the y in the place 0 in the place of?
No, Angel, we have y is equals to 0.
Yes, we have y is equal to 0. We want the input.
0 is equals to 3x minus.
0 is equal to 3x minus. So 0 is equal to 3x minus?
9.
Minus 9. Okay, thank you. Then?
And then we're going to add 9 to both sides because it is a constant.
Add 9 both sides because it's a constant. Okay.
To get 9 is equals to 3x,
9 is equal to 3x, yes.
we divide by 3,
Divide by 3.
we get x is equals to 3.
X is equal to 3.
And we don't have that in the multiple choice, so I don't know how.
We don't have that in the multiple choice. So
Yes, sir.
yeah, if we don't have that in the multiple choice, it just means once again, this question paper,
It's wrong.
it is the question. Yeah, so x is equal to 3, guys. And once again, the question paper is falling short of answers. All right. So imagine now you are this person who really like he does not know, and they made errors, genuine errors, when you don't know how to do the maths, and therefore you can't get to the answers. Yeah. So that's why it's very important that you must know the things that you need to be doing. Okay. Yeah. So here we are testing the mathematics, more like testing the methods that you are using and checking if they are correct. And then checking if you are confident enough to stand your ground when you know something that you have done is correct. Does that make sense? Yeah. So it's fine. This is a nice test of whether you will stick to your guns or you will be swayed by the incorrect answers you see in your options. Yeah. I'm looking at some of you in the comment section. You gave your answers there. Hey, I'm telling you, must be careful. Man. Yeah, some of you were happy to give your answers there, selecting the option. I didn't see anyone who said to me, okay, I see Ilani said answer is 3. Sophie Dessert was like x is equal to 3. And then, you have a few people that basically saw that, we are being misled here by the options that are available. Okay, so good job. Let's proceed to the next one. All right, here we are, 1.7. Simplify the following algebraic expression below. All right, so let's give you guys a few minutes for you to do this one. 4x squared minus 5 plus 8x plus 7x squared plus 8x minus 5x squared plus 7. You have A, B, C, and D. Let's give you guys a chance first to do this one. 1.7.
Algebraic expression.
Sir, can I?
Andy, you've been silent.
So I'm writing.
Okay, so I'm going to give you a chance to do this one, Andy.
I'm done.
Okay, let's do it then, Andy.
But my answer is not here.
Aye, that's fine. Let's do it, Kalok. Let's see your answer that's not here.
Okay.
Okay, must I write down? I'm ready to write down what you say.
So I first grouped the like terms.
All right, meaning you grouped which terms to be specific?
7x squared
Okay, 7x squared
minus 5x squared.
minus, you said 5x squared. Is there really a 7x squared and a minus 5x squared? Yes, there is. All right, and?
And then a plus 4x squared.
Is there really a plus 4x squared? Yes, there is.
Yes.
Okay.
And then I said plus 8x.
Plus 8x. I check again. Is there an 8x? Yes, there is.
And then plus 8x.
Plus 8x. Why am I starting to think there's no 8x? There's no other 8x. Oh, there is. Okay.
Say. And then plus 7.
Plus 7.
Yes.
So 7 doesn't have a...
minus 5. Minus 5.
Minus 5.
Yes, okay. I think mine I did it wrong. I forgot
What?
the 8x. I only put it 1.
Okay, and that is because 8x was a repeating term. So it's easy to think that when you've written an 8x, it could be easy for you to not see the other one. Also, when you rewrite terms and group them, you must always go back and check if you've written all the terms, because it can happen. You see what you've just done, Andy? It is so possible to do all the time. So let's just double check again after writing out the terms that we have written down all the terms, and then 2, always confirm that you have written the signs of the terms correctly, that you didn't change anything, because that's something else that sometimes leads to a wrong answer. Okay, we can continue then.
And then I said 7 minus 5 plus 4, it is 6. 6x squared.
Okay, 6x squared. Yes?
Yes, and then I said 8 plus 8, it is 16.
8 plus 8, it is 16. 16 what?
X.
Thank you, 16x. Then?
And then 7 minus 5, it is 2 plus 2. Because positive multiplied by negative, it's a positive. And then 2.
Positive 2.
Yes, it means it's B.
Oh, so there is the option. I thought you said the option is not there.
Yeah, because I did mine wrong. I didn't add the 8.
Okay. No, it's no problem. It's no problem. Thank you so much. That is beautifully done. I think the masses agree with you. Okay, so let's just be careful, guys, of these minor errors. Okay, so yes, the correct option there is definitely going to be B. Yeah, good job, Andy. Good job, Andy. Okay, 1.8. 1.8. Okay, you can look at that again one more time.
Sprinkles is back.
Yes, Sprinkles, I think, was sprinkling somewhere else.
Sprinkles had to turn to an emergency.
Yeah, emergency. Okay, no, it's fine.
It's 13, sir. Positive 13, B.
Look at Andy. And Andy got an encouragement from the previous one. So now Andy is feeling inspired.
It's B. Even in the comment section, it's B.
Yeah,
Oh,
it
that's
is
why.
B.
So that's why you are getting confidence. In the comment section, they are populating.
I did answer first.
Oh, okay. No, that's fine.
Yes.
That's fine. So guys, do you see this thing? The diagram, by the way, that's there. What do they call this thing? Do you guys know what they call that thing? Yeah, a lot is happening there with sprinkles. I think with the I don't know what's happening there. Do you guys know what's happening? What that diagram is? The one that you have visually there.
No.
We add two.
You remember that thing you guys used to play when you were young?
Yes, we know it, but we don't know what it's called.
Aibo. Hey, guys in the comment section, can you tell? Yeah, there we go. Flavorful sense. It's called a seesaw. Hey, people don't. What do you call it in your language?
Mjingo. Your man, what is it called? No.
You guys.
Hey,
I forgot.
Nata, what do you call it in your language?
Mzwingi.
Yeah, Mzwingi. Yeah. You see, Andy doesn't know.
Yes.
Okay, so yeah, guys, that's what's there, and you can see it's balanced, Moss. It's balanced on the left, it's balanced on the right. So what does that mean? It means that t plus 9 is equal to what? To that 22. Yeah, then we solve the equation for t plus 9 is equal to 22. And I mean, we can do it. Yeah, we have to transpose, 22 minus 9 when we transpose it. So that's very good. You guys, yeah, you see, so we must apply some logic in these things. T plus 9 is equal to 22. Then we transpose, as you said, 22 minus 9. We get, the 13, it comes from there. Okay? Yeah. Okay? Very important. Just nice and sweet and soft and smooth. So our answer there is going to definitely be B.
13.
Okay. Last 1.9. What do we call the following graph type? A, constant graph. B, continuous graph. C, discrete graph. D, linear graph.
C.
B.
C.
Okay.
B.
Oh, we have CB. One side saying C, other one saying B. I wonder what is the correct one for sure.
Linear graph.
C.
Okay, I want an explanation then. Let's have this guy, because this person has also been. He's like, accept my request. Dollar Man.
Hi.
Hello. Hello.
Hi.
How are you?
Minyara, I'm fine.
Are you really fine?
Yeah, I'm really fine.
Oh,
I just
okay.
wanna understand 1.8.
You want to understand 1.8.
Yes.
What do you call that thing there at 1.8? Do you know what that thing is called? Your background is very loud. I can't hear properly.
Sorry, sir.
No problem. Do you see what is on that diagram? There's the solve for t, and then there's the diagram there. Do you see what that diagram is?
Yeah, I can see.
What is that thing called? You used to play on this thing when you were younger. Maybe you still play on it. Who knows?
This thing.
Do you see that thing? Kaho?
So, sir. Yeah, I can see.
You can see it, right?
Yeah, I can see.
Yeah, so what's happening is that there is that, and then they have t plus 9 on this side. All right. And usually, if you have a friend, you would jump on this side and your friend would jump on this side. Ne?
Yes.
Yeah. And then you guys would play together there, you know. Depending on the weight, yeah, things would happen. Eh?
Yes.
Things would happen. Hopefully, your friend has an appropriate, you know, so that you can be able to play properly. But hey, yeah, things happen. What you see now is that this line, it's leveled, meaning you are sitting there, it's equally balanced.
Yeah, I can
There's
see.
t plus 9 on the left, there's 22 on the right. So that means t plus 9 is equal, because when we are balanced with the line, then it means t plus 9 is equal to 22. Okay? So you set up an equation because this is balanced, and that means equal. The weight on this side is the same as the weight on the other side. So we can say t plus 9 is equal to 22. Are we together?
Yeah.
Then you can solve this equation. Have you done how to solve an equation?
Yeah.
Yeah, so then you know that you keep the t on the left, plus 9 is added to t. How do you get rid of 9? You transpose the 9 to the other side of the equal sign. When that happens, the positive 9 changes to negative 9. You subtract, you get t is equal to 13. That is your answer.
Oh, I can understand now.
Are you sure?
Yeah, I understand.
Or another way of thinking about it is, you remember, Mos, in primary, you did those problems that said box plus 9 is equal to 22.
22.
So then
Yeah.
the box here is represented by the letter of the alphabet T. So if you think about it, what number plus 9 will give you 22?
13.
Exactly, you see. So that's just the meaning. By inspection, you can get the number. But also, when you solve the equation, you just take the number added to t or whatever, you move it over to the right. When you do, the sign of the number changes. If it was positive, it changes to negative. If it had been negative, it would change to positive.
Positive.
And then 22 minus 9 gives you 13. So that's how you would solve it in that way. But
Thank you,
anyways, at the end of the day, your t value is 13. That's why we chose B.
Yes. Thank you, sir, for making me understand.
You are very
Thank you so
welcome.
much.
You are very
Thank you so
welcome,
much.
Kahupen. Very welcome. Okay, moving right along. We are now there at 1.9, where it seems like there's a difference in opinion. I've seen the comments in the comment section. Let's just go up a little bit. People are saying many things. Graph type x is equal to 3 minus x is equal to 3 is a vertical straight line, which is a linear graph. That's what Kimi Visuals is saying. Kimi Visuals seems to have quite a bit to say. Let me do this. Let's do this. Kimi. Kimi. Kimi.
Hi, sir.
How are you, Kimi?
I'm fine, sir.
Very well. I just wanted to see, you said the option that is correct for the graph type, you said it is linear graph. Why are you saying it's linear, dear?
Because like between a constant graph always has like the constant graph always the line it's always going horizontal and the vertical line goes straight up and a linear line it's yeah
Okay, so you are saying the diagram that we have there, that curve that we have there, you are saying it is a representation of a linear graph.
Yes.
That's what you are saying. So if I'm to take you correctly, you are saying what we are seeing with this curve like that, this is a linear graph. This thing here. Because that's what they are referring to.
Yes.
Okay. So I just want to correct something here. You guys have done functions, right? Have you done functions, Kimi?
No.
You have not done linear functions here in grade 9. Equations in the form of y is equal to mx plus c. You've not done equations of this form. Straight line. Linear means straight line graphs. So let's just understand the term. When they say linear, okay, they are referring to a straight line. Okay? So the word linear means straight line. Are you with me, Kimi?
Yes.
Yeah, this function here is not straight. Straight line can be manifest in 4 ways. It can either be a straight line that's going up like that. We say it's an increasing straight line. Or it can be a straight line going down like that. That's a linear. So these are both linear. Or it can be a linear function or straight line that is horizontal like that. Or it can be a linear straight line with a vertical line like that. Those are the 4 different types of straight lines that we get under linear. Okay? Is Kimi with me?
Yes, sir.
Yeah, so Kimi, this one is not a linear function. Okay, because it is curving like that. Okay, so it can't be called linear because linear only applies to a line. It has to be an actual straight line. If, for instance, Kimi, they had something like this, okay, then we would have said this is a straight line, definitely. Okay? Yeah, but we don't have that. So we can't describe or say this is a linear. I don't know if I'm making sense. So this is not a linear graph. Nata, you insisted that it is C, a discrete graph. Why did you say it's a discrete graph?
Because it is have a curve now.
Okay.
And discrete graph is a line that have a curve and it's not a straight. Yes.
It's not the straight. Okay. So your understanding of discrete is that it must be a curve in order to be discrete.
Yes.
All right. I hear what you're saying, but I need to explain something in what you have said so that we can have understanding. This, what you have on the diagram, cannot be correctly called a discrete graph, guys. Why can't we call it a discrete graph? Because discrete has to do with when points are not connected You see here we've joined. You see they've marked some points there. 1 and 32, 2 and 16, 4 and 8, 8 and 4, 16 and 2, 32 and 1. If they had marked those points without connecting them, had they not joined them to form that curve, if they were just representing the points alone without connecting them, then we would refer to them as being discrete. With a discrete graph, guys, we don't connect the dots.
Okay.
But if then that is the case, if with a discrete we do not connect, then with this function, what have we done? We've indicated the points, and then we did what? We joined them. All right. So B can be appropriately called a continuous graph.
Yes.
Are we together?
Yes.
So later, because I need to clarify this, discrete graph, unconnected points, not joined. Continuous, the dots or the points are connected. Okay?
Yes.
So that's important. Okay? So B is the correct answer.
Yes, I was
Continue.
correct.
Yes, and you were correct, definitely. You were correct. Okay. You were correct. So I hope everyone else is learning, because remember I said the session is to help us learn. If there were things that we understood incorrectly, we get an opportunity now to clarify for ourselves and have the right and correct understanding.
Yes, Sam.
Yeah. And again, guys, I always say, please, once you know something, hold on to it for dear life. Do not come here next time and I have to be explaining the same thing. Guys, value knowledge when you get it. Value the knowledge when you get it. You guys do angles and stuff.
So can I please ask,
Yeah.
can you please do like not now because now we're busy with this, like when you have time, can you please like do a grade 10 past paper?
So you in grade 10 then, Andy?
Yes.
What are you doing here then?
I'm listening.
This is grade 9 though.
Yes, I'm also doing these things.
Oh, okay. But listen
Yes.
up, Andy. When you should be going to my YouTube channel, because when are you writing?
Tomorrow.
Teeny Andy, what are you doing here?
I'm listening.
No, don't listen to this. There's more bigger fish that you need to fry, you.
I'm listening.
But listen, you can go and listen to me, Kaloku. Listen. You go and listen to me somewhere else. Don't listen to me here, because this is going to be wasting a bit of your time. So for grade 10 content, Andy, I've been doing too many live lessons on grade 10 work. So if you go to my YouTube channel, for instance, you go to my so the link to my YouTube channel is on the bio. You go there, Andy. You will find there. I've uploaded. When was it? I was doing a grade 10 maths paper 1 KZN. I did that paper here on the platform. I've uploaded the video. It's there. You can go and check out my grade 10 maths paper 1 June exam revision 2026. There's too many because I've been doing various papers, grade 10 papers. So you can go there and actually, go through the content and actually watch those sessions. It's because you are here for grade 9. There's other big fish to fry.
I'm learning.
I know you're learning, Andy. I know you are learning, but there's other things you need to make sure that you are learning.
Okay,
Grade 10,
sir.
for instance. So numbers, of course, you may have gotten a lot, gained a lot for your numbers and your number system. That's fine. But now you need to go and make sure that you are able to convert a recurring decimal into a fraction. You know, if you have a recurring decimal, you need to know how to convert it to be a fraction. You need to know how to find the two consecutive numbers that basically a certain irrational number lies between. You need to know how, you need to go ahead and know how to simplify, expand, multiply out. You need to know how to factorize. You need to know how to solve for x. You need to know how to add algebraic fractions, multiply algebraic fractions, subtract algebraic fractions. There's inequalities.
That's simple.
Yeah, but that's simple. Are you saying that is simple? Okay, if you're
Yes.
saying that's simple, that means you are good then. What
The
else?
thing
What
is,
else is?
the thing is
What else is?
functions.
Yeah, functions. Well, you can go to my YouTube channel and go to my functions grade 10. I've done live lessons on just functions for grade 10.
Okay, so thank you.
Go to my YouTube channel and go to the live. The live, there's the tab, the live tab. If you go to the live tab, you are going to see I've done live lessons on YouTube on functions. Your straight line functions, your parabola functions. I've been answering exam type questions there. So go and check
Okay.
it out. And if you feel dissatisfied, you can always come back and then we can see maybe what plan we can make with you. Yo, but yeah, go there, please. Yo,
Okay,
don't come and
sir.
waste.
Bye.
Yeah. Bye, Andy. Bye. I know you like being here, but let's go. Chain, Andy, wasting your time here. You're in grade 10. You can't be here. Okay, Nata, it's me and you, my guy, again.
Yes.
We face the world together, my guy. Face the world together. And
Yeah.
yeah, so Nata, are you guys also doing Euclid geometry here? Geometry of straight lines for
Yes.
the paper you're going to be writing?
Yes.
Like you see 1.10, study the figure below. The angles can be made into pairs of angles which have special names. Find all the alternate angles.
It's going to be
Is that also something that you guys are going to be tested on?
no.
Okay.
No.
I don't know if there's any learners here that are in grade 9 that will be tested on this too. Is geometry also part of the things that you're getting tested on? Just confirm for me, guys, in the comment section. Let me know so that I know if whether to attend to this or not. No, it's not that I don't want to accept. It's just that I've been chatting away.
I'll say.
I don't say how. You are the one that keeps on disappearing. You are playing the disappearing act. It's not my fault. Okay,
No, it's
so
been 17 business days.
yeah, so 1.10. So we must go through it because I see people are saying yes. So even you are going to get tested on this grade 9.
I don't know about that, Nina.
But you said yes, most in the comment section. What do you mean you don't know about that?
When
But you
I did
commented.
not want to, you did not want to answer. Nah, I'm doing way more than angles here.
You are doing what?
I'm doing way difficult stuff than angles here.
You're way more difficult stuff than angles. I'm a parent, Makiti. Which grade are you doing? It's grade 9.
Yes.
Grade 9, sweet M. Grade 9, sweet M. Okay, so let's just check 1.10 then. 1.10 says study the figure below. The angles can be made into pairs of angles which have special names. Find all the alternate angles. Alternate angles are all the angles formed by Z shape between parallel lines. Okay, so if you have parallel lines, the Z shape.
Answer is
Okay.
A.
Sorry? The Z shape, this angle and that angle will be alternate. That angle and that angle will be also alternate if the lines are parallel. So if they're saying find all the alternate angles, the question then is which angles here are alternate? If you look at this angle and that one will be alternate. They are equal. That angle and that angle will be alternate. They are also equal.
Wow.
Okay, so Kimi Visuals is saying A, I think, C is equal to P, D is equal to Q. All right?
Yes.
Okay, that is basically the answer. It's A. If you look at this diagram, this visual, alternate angles means that angle is equal to that one, that angle is equal to that one. If you look at the visual that you have before you, C and P would be alternate. D and Q would be alternate. So it's actually A. All right, it can't be anything else but A. Okay.
Right.
Yeah. All right, let's move on, guys. Let's move on. 2.1. Debza. I see we have a new brother in the midst. Debza, how are you?
I'm good at myself.
I'm doing very well. Are you in grade 9, Debza?
Yes.
Okay. If you look at 2.1, Debza, just look there in the screen. You can see 2.1, Debza? Can you see 2.1 there, Debza? Okay, guys, do you see the question?
Yes.
Okay, between which two consecutive integers is the irrational number square root of 50 lie? So what is your response, guys? 2.1, 3 marks. Obviously, that means we need to show our working. We can't just, how do we answer that question? Tabang, I think, wants to answer it. Let's give Tabang a chance. Tabang, my guy. Tabang.
Can I answer it?
Yeah. I want you to answer me.
Lies. It lies between -8 and -7.
-8 and -7.
Yes.
Why are you saying -8 and -7?
Because you see, when you say it's 7 squared into a fifth squared into 8 squared. Man, what I'm saying for? Oh dear.
So the value is square root of 50. It's not negative, it's positive.
Okay, yeah. You see, square root 7 to the power of 2 will sign like equal to.
So you're saying the square root of 50. So the number 50, you're saying it's lying between which two perfect square numbers? Because we need perfect square numbers here.
8 and 7.
So you're saying 8 and 7. But remember, what is the perfect square number? What is the perfect square number?
49 and 64.
49
Okay.
And 64.
and 64. Okay. Then we can put on the cloak of square root for all those numbers. So the cloak of square root for 64 and for 49 can now be put on, right? And after we've discovered what perfect square numbers immediately lies before 50 and the one that lies immediately after 50. So we have 49 and 64. What's the square root of 49?
7.
And then what's the square root of 64?
8.
Yeah. So 7 and 8 are consecutive. So we can say the square root of 50 lies between 7
and 8.
and 8. Yeah. Okay. So this is important. If there's the square root, then we look for perfect square numbers. In a live lesson I did earlier on, they asked about I was doing a grade 9 live lesson and they asked, find the consecutive integers where this number lies between the cube root. So it was not this time the square root, but it was the cube root. How would we do this one? The cube root of 15.
Okay, we want a.
So would we still look for perfect squares, guys?
Yes.
No.
Be careful.
Please.
Would we still look for perfect squares? Because with the square root,
No.
we look for perfect square. With the cube root, do we still look for perfect square numbers?
No.
What do we look for if it's not perfect squares?
It's perfect. We look for.
Perfect cubes.
Thank you. Perfect cube. So remember, for perfect square numbers are perfect squares because we had the square root. But if we have a cube root, then we look for perfect cubes. So now we need to think for 15. What is a perfect cube number that comes before 15 and one that comes after 15 for our perfect cubes? And remember, perfect cube numbers here, we have 1, we have 8, we have 27. All right, these are some of the perfect cube numbers.
It's 8 and 7 and 27.
Okay, 8 and 27.
What the network? Network. Oh, I'm coming back now. Why?